Good morning, students. I will teach today complex number cube root of unity. Okay, cube root of unity, right? Cube root of unity. Okay, and complex number previous class everything I've discussed now. Your modulus of the function, complex number, argument of the complex number. Okay, all of you know argument. Yes, modulus also. Suppose x plus iy modulus will be root under x square plus y square, and argument will be tan inverse y by x, and your principal value of the argument minus pi 2 plus pi. Okay, okay, and modulus z1 z2 equal to mod z1 into mod z2, mod z1 by z2 equal to mod z1 by mod z2, also argument z1 z2 equal to argument z1 plus argument z2, etc. Okay, now look at here, cube root of unity. Okay, here suppose cube root of 1, suppose x, then x is cube equal to 1. Okay, x is cube equal to 1. So you can write here x is cube minus 1 equal to 0. Then x minus 1, x square plus x plus 1 equal to 0. Then you can write x equal to 1. And x equal to minus b plus minus b square minus 4ac by 2a. Okay, by 2a. 2 into 1. 2. That is minus 1 plus minus. See, this will be root minus 3 by 2. Okay, then minus 1 plus minus root 3i by 2. Okay, see here quadratic formula, minus 1 plus minus root 3i by 2. Okay, now look at here, 1 is real, remaining 2 here are imaginary. See, no? So 3 value of x we are getting. First one 1, second one minus 1 plus root 3i by 2, and minus 1 minus root 3i by 2. 3 values we are getting. Okay, 1 is real, remaining 2 are complex. Okay, now suppose we are considering this one complex root be omega. Let one complex root be omega. We are considering. Now, if so write omega equal to write minus 1 plus root 3i by 2. Okay, minus 1 plus root 3i by 2. Now squaring both sides. See, omega square equal to 1 by 4, here 1 minus 2 root 3i plus 3i square. Then 1 by 4, 1 minus 2 root 3i minus 3. 1 4 minus 2 root 3i. Okay, so it will be minus 1 minus root 3 I by 2. See, so omega square we are getting minus 1 minus root 3 I by 2. See, we are solving this one, minus 1 plus root 3i by 2. Okay, this one omega, and its square will get this one. Okay, similar way, if you do this in omega, this is omega, and its square, you will get this one. So one complex root be omega. If one complex root be omega, then other complex root is omega square. Keep in mind. If one complex root be omega, then other complex root is omega square. Okay, so we are getting 3 root of 1, 3. So we are getting 1 omega and omega square. Okay, 3 roots are there. Okay. And sum of the roots, see, suppose 1 plus omega square. So we will 1 plus, this will minus 1 plus root 3I by 2 and minus 1 minus root 3I by 2. After simplification we will get half root 3 by 2I minus half minus root 3I. So this is cancelled, 1 minus half and half 1. So 0. So we are getting 1 plus omega square equal to 0. Okay? 1 plus omega square equal to 0. And from here we can write 1 plus omega square equal to 0. So 1 plus omega minus omega square, 1 plus omega square minus omega, etc. And omega plus omega square equal to minus 1. Right. Okay. Again, now I am finding omega cube. Omega cube finding. Okay, omega cube. So omega cube, right? Omega into omega square we can write, no? Okay, omega cube. Okay. Now, omega value minus 1 plus root 3I by 2 and minus 1 minus root 3I by 2. So that is minus 1 whole square minus root 3I whole square by 4. So it will be 1 minus 3I square by 4. So 1 plus 3 by 4 equal to 4 by 4 equal to 1. So all remember omega q equal to 1. Remember, okay. Suppose multiple of 3 is 1. Okay. Omega multiple of 3. So write omega 3 to the power n equal to 1. N being any integer. Okay. Any value of omega. 1, 2, 3, 4, 5, etc. You put here. N equal to here. Okay. So you will get 1. So remember omega q equal to 1. Okay. Now Suppose write 1 minus omega 1 minus omega square 1 minus omega 4 1 minus omega 5. What is the value? Okay, 1 minus omega 1 minus omega square 1 minus omega 4 1 minus omega 5. What is the value? So write 1 minus omega 1 minus omega square. So 1 minus omega cube into omega we can write now. See? You can write. And here 1 minus omega into omega square. Now 1 minus omega 1 minus omega square. So this is omega 1. So write 1 minus omega 1 minus omega square. Okay. Now 1 minus omega into 1 minus omega square whole square. So now write 1 minus omega square plus omega cube whole square. Now omega cube value is 1. Omega 1 plus 1 2. Okay. So write 2 minus, take common 1 plus omega square give whole square. That is 2 minus this value. Yes, minus 1. So minus 1 plus 1. So plus 1 whole square. That is 9. Okay. Next proof. Again, suppose 1 minus plus omega minus omega square into 1 minus omega plus omega square. What is the value? Okay, 1 plus omega minus omega square and 1 minus omega plus omega square. What is the value? So right. So we can write 1 plus omega square minus 2 omega square. And here also 1 plus omega square minus 2 omega square. Okay. So this value will be 0. So minus 2 omega square into, here this also 0, minus 2 omega. So 4 omega cube. So 4 into 1, that is 4. Because we know the omega cube is 1. Okay. So next one. Again, suppose 3 plus 3 omega plus 5 omega square whole to the power 6. What is the value? What is the value? Now write, you can addition 3 plus 3 omega plus 3 omega square plus 2 omega square, we can write now 6. Okay. Now 3 plus 3 common 1 plus omega square plus 2 omega square whole to the power 6 is there. Now this value will be 0. This is 0 now, 0. So 3 to 0, so 2 omega square whole to the power 6. That's 64 omega to the power 12. So 64 into 1, that is 64, because omega 12 is 1. Multiple of 3. Okay, this is multiple of 3. Omega 12, so the value is 1. Okay, the value is 1. Next one. Suppose I am doing factorization. See, suppose a square plus 1 factorize. What is the value? So you can write here a square plus I square minus I square, you can write now. I square value minus 1. So minus I square will be plus 1. Now write. So a plus I into a minus I. So this is the answer. Again, suppose a square plus ab plus b square. Right. A square plus ab plus b square. So you can write here a square minus c omega plus omega square ab plus b square omega cube by 2. See, this value is minus 1. Okay, so it will plus 1 and b square omega cube 1. Now multiplied a square minus omega ab minus omega square ab plus b square omega cube. Take a common, a into omega b minus omega square b common, a minus omega b. That is a minus omega b into a minus omega square b. This is the answer. Right. Okay. Okay. Now, suppose square root of I, see, square root of I, find the value. So I you can write half into 2i, no? Half. So 1 plus 2i plus I square. So I square minus 1, you know. Okay. That is 1 by 2, 1 plus I whole square. I. Okay. Now, square root of I plus minus 1 by root 2, 1 plus I. See, this is the answer. Okay, square root of I. Okay, again, 7 minus 24i. See, 7 minus 2 into, we can write 12 by now. Say 24, 12i. So right, 7 minus 2 into 12, we can write 4 into 3i. Yes. Now look at here. 4 square will be, we know 16, and 3 square we know 9, no? So 16 minus 9, you will get 7. See? So 7 we can write 16 minus 9, minus 2 into 4 into 3i. 16 you can have 4 square, this is 3i whole square, 2 into 4 into 3i. So right, 4 minus 3i whole square. Say, a square plus b square minus 2ab, a minus b whole square. Okay? So square root is there, 7 minus 24i, 4 minus 3i, plus minus. Note it down. Okay? Suppose 1 minus I square root. So 1 can half, 2 minus 2 I know. So half. 2 can be root 2 plus 1 minus root 2 minus 1. 2i we can write now. And equal to half. This part we can root 2 plus 1 whole square plus I square of root 2 minus 1 whole square. 2ab root over root 2 plus 1 into I of root over root 2 minus 1 we can write. Okay? Now half here root over root 2 plus 1 minus I of root over root 2 minus 1 is whole square. Okay? Now square root will be right 1 plus 1 minus I plus minus 1 by root over 2 root 2 plus 1 minus I of root 2 minus 1. Okay? This one. Copy it. Very important sums. This one very, very important sums. Okay? Okay, again next few important sums I will discuss. Okay? No more today.